So, hello everyone. My name is Dharamveer Kumar, and I'm a PhD candidate at IIT Bombay. I'm basically an aerospace engineer, but I'm interested in mathematical analysis, and my PhD work is also in that. Okay, so a couple of things. This session is being recorded, and I have already taught this course, I think, last year. Another thing is when you have to raise a question, you can just type it in and then when you have to raise a question, you can just type it in the comment box because I'm not able to listen right now. So whenever you type it in, I will put my earplugs on and then we can have a conversation. And since this session has been recorded and it will be on YouTube, if you have any objection to the recording, you can tell me. When you ask a question, I will pause the recording, and whenever I'm answering, I will just resume it. Okay, and I'd really like that if you ask me all type of questions. Okay, so this is so I'll start with. Okay, so you're asking what's the YouTube channel? So that will be uploaded later, all the videos and what the YouTube channels are. Okay, so it's the YouTube channel only for this NPTEL course itself. I'm not uploading anything as of now, but it will be shared with you, all the details of the YouTube channel. Whatever I'm writing, that will also be uploaded, and you can ask questions. I would really like that if you ask questions a lot, because that's how you learn real analysis. Okay. Okay. So we are gonna solve. So how many? Just raise your hand. How many of you have solved assignment 0? There was assignment 0 already. Yeah. Okay, a lot of people have raised their hand. Were you able to solve everything, or was there any doubts that you had? Okay, I'm assuming that you're able to solve everything. Okay, but still, I'll go ahead and put everything down here. Okay, so I'd like to know one thing. How many of you are from like mathematics background, like doing BSc or MSc? Just raise your hand. Okay, I think almost all of you are from there. Okay. So, just one thing, do you just want to understand like this assignments, or I would like to give you a larger idea. Like I think you guys understand in terms of, and you can speak. I would really like when you speak. Would you like a larger picture as well, like how this fits in a topological space or a metric space, or you're not comfortable with it? Yeah, go ahead and you can speak. Don't worry, it's not a viral YouTube channel. You'll not get noticed or anything. You can say whatever you want. Okay, larger picture is fine with people. One person said, okay. Okay. What is your background? Can you tell me a little? Okay, control system background. Okay. Okay. So right now I'm not going to talk about convergence sequences and everything. So right now we are going to talk about the assignment 0 part, which is about what the functions are. Oh, you cannot. Shamim cannot hear me properly. Oh. What about others? Shamim, can you take out, like, check your earphones and everything? Yeah, it's audible to people. Okay, I'll try to speak loudly. If it is not audible to you, I've just listened to you what the version that's going to be uploaded on YouTube. It's clear. So if not clear, you can watch that and ask questions next week. Okay. It's going to be a 2-hour session. So I'm going to like try to include every one of you. Okay. So there's a question. This is going to be assignment 0. This question is straight, true or false. So this function from R to R such that Venkatesh, why have you raised your hand? Okay. So this function is injective. Do you guys understand that this is like 11th, 12th maths? I think you all understand what is injective, and injectivity is not just about functions from R to R. This is what I was talking about. So like I will solve this problem, but I will give you a larger context as well. Okay? Yeah, so it could be from function, general function from X to Y. I don't know what's happening. Why is someone given admit all? I'm not going to take anyone from that. Okay, so fx is injective, like sin x is injective. So let's see what happens. So you simply draw a function. And injective means for each function, like, so you want to solve in general, right? Solution is. So to check injectivity, again, we are solving it simply, we can see it from the graph, but when we want to solve in general, what do you do to check a function is injective? So if, like, let x1 x2 belong to, so like let's say we have a function from x to y, okay, and so I'm assuming you understand what this is, domain, and this is a codomain, and x1 x2 belongs to x. Okay, what is the definition of function? For each x, so like for f of x1, there is an element in y, right? for x2 there is an element in y. It's not necessary that both are different. So like let's say this is x, this is y, there are two elements. They can correspond to the same thing or different things depending on the function. But it cannot be, for a function, it cannot be something like this. Like f of x1 cannot be two things in y, two distinct things. Okay? If this is the case, it's called a relation. It's not a function. This is a case of a function. So when we say it's injective, okay, what it means is that you take, so let's say this point is distinct. So for x1 not equal to x2, you have these 2 points. Show that f of x1 not equal to f of x2, and this is injectivity. So is it injective? So let's say for example our f is sine, right? So if I take sine of pi, right, and sine of 2 pi, both are 0. So that means this sine pi equal to sine 2 pi. That implies f is not injective. Associated with this, there is a concept of surjectivity. So this is how you do it in general. Like it doesn't have to be R to R. Okay, this concept of injectivity is just applied to, like, this x could be any set, y could be any set, so that a function is defined. Okay. Surjectivity means, I know you have learned this in like high school, but I'm just trying to, like, for those who are not clear, I'm just trying to give them a perspective. There is an associated concept with injectivity. It's called surjectivity, and when the function has both, it's called so when function has both, so surjectivity plus injectivity is called bijectivity, and when this happens, you have invertible function. Okay. So what surjectivity means is, again, so over here when we have a domain, I said for any, so like let's say there is x1 and x2 in X, for f of x1 and f of x2 exist, they are something, but it doesn't mean, so when I have given f of R to R, it doesn't mean like sin x has a limit, right? We know this. Sin x can only go to from -1 to +1. So it's not taking all the values of R. It's a function, but it's not taking all the values of R. So when for some functions, when it takes all the values of R, for example, when f from R to R this is surjective. I'm giving an example. When I say something like this, so whenever you're defining a function, always give domain, codomain, and associated. Just 1 second. So in mathematics, whenever you're giving a function, right, you have to always give a domain, codomain and what's the form of the function. Can someone tell me if this function is surjective or not? This function is in the question. Is it surjective or not? It will be fun. See, I know it's starting with very basics and everything. Eventually, if you interact, it's going to be fun. I'll ask them good questions. The topic is very simple right now. I understand you're all math graduates. You can type it down. Yeah, okay. Yeah, so it's surjective. Yeah, it's not injective. Yeah, still, but it's surjective. Can I write? Okay, just can I write something like this? What is this? It's not a function anymore. Do you understand what I'm saying? So to make it function, what you do is you take a domain, this is a subset of R, in which it's going from 1 to 2. So what will be the domain? So when you draw a sin x, you're taking only the positive things. So this is the domain. I hope you are able to understand that. So this is not a function, not a function. This is a function. You have to define some domain, and these ideas are not usually used in for functions, for simple functions, because whenever we give this, we state that as a domain. But when you go to very big operators, linear operators, you actually define a domain where it is the function is or the operator is well defined in a larger space. Okay, because the operator sometimes may not be defined on the whole space, because in this side the codomain is limited, right? So this is not a function anymore, because for each one of them, this is not a domain anymore, basically, of this function. So you need to define a domain, and then now this is a function. Still not bijective, still surjective. If you have any doubts, please let me know. And I hope you are learning something new, or looking at things in a new light. That's my goal, actually. Yeah. Just have a look. This so you don't need to write it down. This will be uploaded, and you will be shared all the details. All I want you to ask questions if you have any, and try to engage in mathematical sense. Okay, so if you don't have any questions, I'll move ahead and I'll write another question. Okay. for any three sets ABC, is this true? Anyone? Basically, I'm asking if union can be distributive. Okay, so I'll answer this. So I'm hoping you understand what A cross B means. So like basically X cross Y means all the pair of XY if you don't understand the symbols, just let me know. So basically if you have a set X and you have a set Y and these are elements in X and Y, you take all the pairs. For example, these two are sets, and what we can do is this a set? Because you have two so in set you want to have a distinct element, so like let's make it 2. Okay, now this is a set, and when you want to take X cross Y, this is nothing but you have 1 0 1 1 0 0 0 1 2 0 2 1, and these are the elements. So again, so this is by pair, and then you have to take union with it. Can anyone tell me why this is wrong? Yeah, please tell me why is that. So very good. So this was a question last year, and many people answered true, but this is wrong. There is a obvious typo in this. Yes, very good. Yeah, thanks, Siddharth. So this was a typo and in NPTEL course last year. So the correct form is A cross B means C. But this is distributive order. This can be eliminated by a simple elimination, you can say. Like think of it, Let A, B and C all be like just 1. Let A equal to B equal to C be all 1. Okay, so what is B cross C? And what is A? And what is their union? Phi. There's no union. In fact, this is always going to be phi. So, are you saying these are two binary operations? So, any two binary operations are always not distributive. Like you have seen with this with multiplication. Like, so if you have something like this, right, in multiplication, B plus C, right? So you write AB plus AC. So these are again two binary operations. They are distributive. You can distribute them like this. I would try to write like this. Not all two binary operations are distributive. That's why it's important to understand the properties of any binary operation, like multiplication, addition. They are taking two things and giving a new things. Himanshu, no, all of them are not in union. Union is so this is the correct form. I'll tell you how. Himanshu, do you like to speak up? What are you trying to say? Okay, I think it's clear to you now. Okay, so now this is a distribution. Now let's see if I do this. What? So B cross C is what set? Okay, so sorry, my bad. So B cross C is this set. So the element is this 1, 1, and in A the element is just 1. So if you try to understand it in a two-dimensional plane, 1, 1 is this point, and this 1, actually you cannot represent it, but think of it like 1, 0. Oh no, sorry, that cannot be true. So basically it's an element of two different dimensions. This is in one dimension, this is in two dimensions. So there is no union. So that's why it's right. Yeah. Okay, just a simple example if you want to say like in real numbers itself, can we write it something like this? Can we replicate the same thing? This is wrong, right? Oh, Siddharth. Okay, so when A, B and C is like 1, set is 1, you want to write B cross C, this is this set, right? It has singleton element 1, 1 and A has just 1. So what is the union? Oh, sorry, I was doing intersection, my bad. It's this. Sorry. This is A union B cross C. Okay, and what about A cross B and A cross C? So A cross B is itself and A cross C is also this. So when you take the union, I was thinking about intersection, yeah. Yes, union intersection. So the right hand side will not have this single elements. And the left hand side will have these two. So that's why, like as you can see, they are not same. I think it's clear, Siddharth? Similarly, this is wrong, this is right. all the binary operation over other is not distributive. That's what I wanted to say. But this is. So over here also the Cartesian product union acts like addition, and the Cartesian product is distributive over. So this I will prove now. And this proof is really simple, but I will like you to understand so whenever there is an equality between two sets, can you tell me how do you do check? Like when do you say that two sets are equal? So when you say x is equal to y, you have to show that x is a subset of y and y is a subset of x. You cannot just count the elements and say that they have same number of elements. You can say that for finite set, and a lot of things needs to be there. They need to be of same size, they need to be have same elements and stuff like that. But for infinite sets, like let me give you that number of elements, yeah, or like size of natural numbers is same as size of, or we call it cardinality. So size is a very weird concept, so that's why we don't go with size, and for x equal to y do simple things like this. So how do we do it? So assume this is x and this is y, and whenever you say this is the map of proving this, that let x belongs to x, then prove with your logic that x also belongs to y. Now this is one side, this implies that x is a subset of y. Now let some x belongs to y, and then you prove, you do something and you prove that x belongs to x. This implies y is a subset of x, and that implies x equal to y. Okay, this will be the roadmap whenever it comes, like you have to prove. If you cannot do this, they are not equal. Okay. So A cross, so there is a cross between there, so the element will have a form, something called x comma y. Okay. So let xy belong to this, implies by definition that x belongs to A, y belongs to B and C. So this, what does this imply? Y is either in B or in C or in both B and C. Okay, somewhere it is. So either in B or C at least. So now A cross B union A cross C. So you do this, what does this mean? That xy will belong to this. So is A there is X in it, there is some B union C, and Y is somewhere. At least it's without loss in generality, you can take at one place. So when you do A cross B, XY will come in there. If this Y lies over here, then again that case is satisfied. Let's say it does not lie in B, it lies over here, it comes in A cross C. Okay, so this tells us is A cross B union C is a subset of and you need to understand this in very simple settings, so then later you can go and do it in like tougher or like difficult sets. Okay, similarly, this is a very simple example, but the roadmap will be same. And you might think, okay, why I'm doing this all like difficult unnecessary things. We'll see later that why it is important. So now let XY belong to A cross B union A cross C. What does this mean? This implies X belongs to A cross B or A cross C, like either of them. X belongs to at least B or A cross. Okay, that implies X definitely belongs to, so either whenever if it belongs to A cross B or A cross C, in both cases X belongs to A. Y can belong to either of them. So this means, so let's take case 1 when XY belongs to A cross B. So when XY belongs to A cross B, then X belongs to A, Y belongs to B, that implies Y belongs to B union C, and the case, another case is that XY belongs to A cross C. In this case also this is the case. The conclusion is same, that X belongs to A and Y belongs to B union C. So that implies XY belongs to A cross B union C, hence if something is not clear, you have to tell me now. And for that purpose only, like there were solutions already uploaded, you can see the solutions. So all your thoughts should be clear. If you don't want this to be recorded, I will just pause it. I'll pause the recording and I can help you explain. Okay, so next question. So whenever I do this, it's going to infinity. So this is just a set of whole numbers, you can say. And now let's say I define, and I'm writing this as, in mathematics we write it like this. Okay. Okay, I'll give you a second to think about this. Anyone? So, okay, if it's not clear, this signs mean, so start with 0, so minus 0 to 0. Anyone? This means this thing. And so on. And this means and so on. Siddharth has written the answer, but is it clear? So this, what is this? How about this? How do you remove this? Only this. So this part basically. So whenever you don't know anything, just whatever you know, you can do this. This is nothing but you're taking an intersection. That's it. This part, like whenever you want to say, this is basically phi because there is no element in. So whenever you have like phi intersection with anything, it's phi only. Just give me a second. And yep. So basically A is phi, and then in terms of B, if I do this, this is, so whenever I do minus 0 to 0, this is nothing but a 0 set. So in 0 intersection with minus 1 to 1, this is nothing but 0 set. Solution. Yeah. Okay. So yeah. So this is 0. This is minus 1, and this is 1. Okay. And when you are taking intersection with something larger, you remain with the smaller set. So even goes for like all larger sets, all are larger than minus 1 to 1, and the intersection is only this. This is intersection. Is this clear? You've raised hand. MA221. Remove that. Yeah, please ask. Yeah. Oh, that's so I have defined what this n is. There is a 0 as well. Yeah. No, so what I'm saying is the natural number is defined with 0. Yeah, over here I've mentioned it in the question itself that n is this set. Yeah, so sometimes it's very confusing. Some people start with 0, some people start with n. So many when you want to start with 1, you write n plus sometimes. So that's why it's better to define what this n is always. Yeah. So let me save the recording. Okay, so let's move on to the next question. This is a good one. So now you can see there is z plus. That means it starts with 1. So this is a question. Let me write it properly. So this is an optional question. You can check from the options itself for those who are like just want to solve this problem. There are options. But how about we try solving it without options? So this is the problem. That I want to teach you like what induction is. Okay, to understand induction properly, it's good question. So like all these topics are like trying to teach you more, how do you say, the methods that will be used in like real analysis and so on for them. Okay. So for these type of questions, you need to assume a function and then go on and how do you say, prove it by induction. Okay. Okay, this is what I think, and this is how it's gonna go. Okay. So I'll give you example. So can you show that this is satisfied? So we are seeing a pattern, right? This was like 2 plus 1, 4 plus 1. So it's like 2 to the power 0 plus 1, 2 square plus 1. So does it satisfy this? Let's check. 3 into 2 to the power n minus 1. is nothing but 1 plus 2 into 2 to the power. This is whenever you're given a form, you guess it and you try to match this. Clear? And now let's come to like the usual induction that we do. So we have to prove by induction. This is another type of induction. You guess this form, you guess the function and then satisfy it. This is the typical induction that we use. Check for n equal to 1. N equal to 1, you get 1 into this is 1. This is equal to 1 square. It is satisfying for 1. Okay. So basically what we have, there is something over here, there is something over here. Okay, and this side, both the sides are satisfied with n equal to 1. Okay, so now what you want to see, is it satisfied for n plus 1 as well? So there is n square over here. So for n square, we have this plus n plus 1 square, right? Then what do we do? Take n plus 1. Okay, multiply over here. N into 2 plus 1 plus 6n plus 6. So what you want to check if the same thing is satisfied when we put n plus 1 over here. So what is the expected form? N plus 2 into n plus 1, 2n plus 1 plus 1, right? By 6. 6 is already there, n plus 1 is already there. So you want this over here, this kind of thing, which is what is this? From here, what do we have? 7n plus 6. Same thing. So this is nothing but n plus 1 into n plus 2 into 2n plus 1, 3 by 6. So you see how induction is working. I know it's a very simple thing, but this is how you want to start induction. So you have two expressions, f of n and then g of n. F of n is controllable, like you know how to sum this, right? G of n is a resultant thing. So if this is valid for f of 1, you want to guess, like this is a guess thing. And if this is true, because for 1 you can calculate everything very easily, and if f of k from here, you assume this and then you show, then this form is satisfied. Because this is satisfied, this implies so this is true for or. So in case someone's like induction was not clear, this is the induction. Now let's come to like the first question of a very basic real analysis. The question is it true? So this is a symbol for every x belonging to real number. This is a symbol for there exists n in natural number such that what do you think by intuition? Anyone? True, false? Anyone else? Yeah, please say MA2211. It is false? Okay. So you give me a real number and I will give you a natural number. Yeah. Can I give you one? And yeah, go ahead. Which is greater than this, right? Yeah. Yeah. That is okay. This is not saying that. It's saying that you give any real number, I can find a natural number greater than this. Okay, you guys are like interacting a bit. Usually it doesn't happen with NPTEL students. So okay, so I'll give you a question related to this. Is this true? like this is not terminating, it's going to infinity. Is this true or false? Can anyone prove it? Siddharth, Himanshu, Ramya, like just orally, can you prove it? Okay, yeah, very good. So this comes from a sequence thing. So whenever you're saying this, there's a very precise way to define it. Like when you're learning sequences, is so this is, you can number this, right? So for every epsilon, you've learned this, right? For every epsilon greater than 0, there exists a natural number such that for all n greater than m, so like when you want to define this, xn converges to it, so xn minus x is bounded by epsilon. Okay, and now assume this sequence: x1 is 0.9, x2 is 0.99, x3 is 0.9999, okay, and so on. And this is the infinity. So basically, if you can say that x, can you say that this is the problem? This is the problem. And since 1 is definitely greater than this, so this mod is nothing but, you can write it in this way. So can you find an epsilon such that x is 1? Can you find in this sequence, can you find something epsilon such that for after that everything you do, it's greater than 1? So you choose any epsilon, okay, any epsilon. You'll always find a number smaller than that in form of this. So like I'm going to do this. Okay, you want to find for a given epsilon, you want to add something to it such that after that all the numbers, it will be greater than 1. Okay, so let's say you find some epsilon. Okay, you can always find something of the form this. Which is smaller than that. And whenever you want to like subtract this, this won't be true. So you should try this. I'm going to tell you now, but you should try this. So this is what it means when you are learning sequences. This is where you apply it. But like by seeing a similarity, can you say this? After this I will tell you what else. Can you say this? Is this true? Or does 9 has something special? is definitely false. After 3 3 you do anything, there's this, there is a number between them. Okay, with 0.99 what happens, the special property is, so whenever you want to add anything at any place, at some place you want to add like 1, right, a small quantity, and this goes on, right? Any small quantity whenever you want to add. Okay, this becomes greater than 1. If you see, this is 99999, and this becomes 10, then every number becomes 0, and this becomes 1. So you add any minuscule thing, shoots. So you cannot find any number between them. Yeah, good example. So anything like this is there between them. Okay. So how are we gonna do this? Let's start with this, and we'll go to sequence later. And we call this method a contradiction. Okay. So let assume, we are assuming there is no n such that in other words, for all n in there exists a natural number such that for all n greater than m there exists a epsilon r such that and this is the definition of, so when n can be larger and larger, so this will imply that x is, because n can go to infinity, x is greater than infinity, and that's a contradiction. Something not clear? Oh, you did not understand, Karthik? Okay. I'll explain this again. So, if you understand, this is the question. So this is a real line. Okay. And I'm saying, give me any real number. Okay, here's 0, like this. Give me any real number, and I can find a natural number which is greater than this. So in practice, like I give you like 1,033.7 blah blah blah. Obviously, you can find a, like if you do a decimal representation, you take a greatest integer of that, and there is a natural number. But you need to prove it more rigorously. Okay, I'll go more. So the proof was semi-rigorous. I'll go more rigorous. So you understand this, right? Okay. What does this mean? Like, we haven't defined infinity. What does this mean? And even like, how do we say this rigorously? Okay, so understand from that point, it's not bounded. It's going above and above. Okay. So now, so we have to choose for all x in R. So for x less than equal to 0, the natural number is, choose n to be 0, and then x is bounded by n. This is case 1. Okay, that's done. So for x, any x greater than less than equal to 0, I have found a natural number n equal to 0, and we are done. Right, now this is case 1. Now let's go to case 2, when x is greater than 0. And you have to find, given any x, I have to find some natural number greater than this. In practice, this is the ceiling, we call it in computer science. So this is a ceiling that we're trying to find, if there exists or not. Okay. So this is what is called contradiction. That let's assume that there is no natural number greater than x. So let's assume for some x in R, there's no need of equality, but yeah. So let's say for some x in R, there is no natural number like this. What will this mean? That for all natural number, this is pure logic, for all natural number, this is the case. This implies that this is the case. But if this was the case, we can take limit n goes to infinity. It's unbounded. Okay, and this will go to infinity, and x will be greater than infinity. And for real numbers, that's not true. That is one of the definition when we define real number. This is a contradiction. Is this clear, Karthik? Okay. Now, coming to question 7. this is again we have done this, but we did it with the intersections. I want to do it with union now. Again, n is, we're defining it with 0. And then intersection of n in z plus. Z plus is 1, 2, blah, blah. Can anyone tell me what this is? What these two sets are? Yeah, Shubhma is right. Oh no, Shubhamoy. Shamim? No. The second one is correct. Yeah. So Shubhamoy, like B is not empty, it has to be 0. And it's not R, say that it's R plus. Not R plus like 20 minus 0. Or R plus union 0. Okay, so I'll explain this. So the first one is, so different is, so 0, 0, union, 0, 1, union, 0, 2, union, 0, 3, and so on. This is just 0. I have to show again, see, I have to show this that A is equal to, when it was intersection, it's easier, like you can go to infinity, the smaller sets are there. For intersection, you need to prove this. You cannot just say, okay, this is true. Intersections are easier. Yeah, Shilpa, you want to say something? Okay. Yeah. All the real numbers, yeah. So whenever you are meaning this interval, we are meaning like in real numbers. Yeah. So yeah, good question. So I need to show that these two are same. Okay, this is still a question. So I need to show that A is equal to, okay. So right now, let's got this some A prime. So let x belong to A. Then x is either 0 or this. So x belongs to 0 set or this and this or so on. So it could be some positive number, or sorry, non-negative number. This implies that x belongs to it could be anywhere. Like I've chosen arbitrary x from this A. It could be anywhere. So this will definitely belong to a non-negative number because all are positives. So that implies A is a subset of A prime. Now choose x in A prime. So it belongs to some non-negative number. Okay? And what we have learned, and it's some real number, non-negative number. So what have we learned? So there exists a natural number such that we just proved that, right? And whenever we do this, we can pick the smallest. So if there is a natural number greater than this, we can always pick a smallest natural number. Because whenever a number is bounded from below, that's why the natural number have a lower bound. So whenever it's bounded, we can pick a smallest natural number such that. So that implies x belongs to x belongs to A. Okay, so now you must be thinking like, what is the use of the Archimedes principle and stuff like that. So this is how you like prove stuff. So that means this is equal to zero to, and let's go to 0 to 1. Okay, yeah. Okay, so what I'm saying is, so you have some x, and we have already shown that there is some natural number greater than this. Okay, so if you have studied the field's natural number, whenever these or integers are bounded from below or above, we can find a lower bound. Like the smallest natural number which is greater than this, sum and stuff. What? Yeah, which is very near to x. Yes, yes. So from there, it will lie over here. Yeah. Again, note that this is again semi-regress because I have not stated the properties of natural number. So that is a little more involved. You need to understand fields of natural number, fields of real number, what they are, to go more rigorously. This is a semi-regress analysis. So we don't have time to like go through from like JFC axioms. But yeah, no, I'm telling for others. Yeah, yeah, yeah. So that we cannot go from JFC axioms. So, but like yeah. So there is one thing. If you're interested in this, um, try to prove that between two real numbers, any real numbers distinct, so that a not equal to b, there exist infinitely many rational and irrational numbers. This will give you a lot of clarity into fields, like how do you approach fields of real number. Okay? Let's go to this question. And tell me, is this true, false? Can you use what I have? Yes, that is true. Can you just quickly use what I have already told? Like it was distributive, right? And the cross. So let me tell you, A cross B is same as A cross in sets Cartesian product. Is it? For what kind of things it is same, or for what kind of things it is not same? Or is it same? Yeah. So this is not true, but is this true? Tanisha, you're saying the second statement is not true? You can speak up or just type it, because we showed this, right? We showed this part. Can you show this? Yeah. So in the same manner that we have shown this can be shown. And we just need to apply these two to get this. It will be really cumbersome to start with again proving this. So you need to remember the distributive laws usually to understand this kind of problem. Can you see if we use these two, we can get. I'll just write it down. So I'm using this. And in both, I use this. And then there are all the unions. So this is equal to RHS. So this is not true, but the distributive laws from both the sides is true for Cartesian product. So why I'm insisting on knowing this, you must have I remember in NCRT of 7th or 8th, they give all these associative laws, distributive laws for plus, minus and whatever. That is the definition of addition and stuff. People leave it they learn the application, but they don't know what the definition is. And that is problematic when you study mathematics at higher level, and when you want to construct your own definitions, because definitions are nothing but you have to define a properties. I'm assuming you have seen vector spaces and stuff like that. So they're defined by the properties. These are the properties. If some set satisfies that, it has a special character. So let's say you want to define your own space someday when you're doing some mathematical work. You should know these are the basic properties that you need to be careful about. And the cross operations. Okay. Let me see what questions are left. And the questions very simple questions okay, these are very trivial. So f goes from R to R. F of x is 2x plus 5. Need to find range of f. Let me ask you this before moving to the solution. Is this a function? So that when you draw a Cartesian in Cartesian coordinate, this line is called x is equal to 0. Is this a function? So basically this line you can define as a Cartesian product, right? This line is a representation of this Cartesian product. Is this a function? Sorry. Yeah. You guys understand a function is nothing but a subset of this Cartesian product of codomain and domain. So I'm asking if this subset, so the basically this is R cross R, this is the whole Cartesian plane, and the function are nothing but a subsets of this R cross R. If something is not clear, you have to ask me. So all I'm asking is 0 cross R, it's a subset of R cross R. Is this a function? I've drawn the line as well. You can understand from line something is a function or not. This is a binary question, yes or no. Oh, Karthikeyan. Okay, so let me tell you something. You understand what sets are, right? And what the Cartesian product is between two sets. I can define it that again. You can type it if the Cartesian product is clear for you or not. Okay, Cartesian is clear. So let's say you have a set X and Y, and then we have a Cartesian product. A relation is a subset of X cross Y. We define this relation as a subset of okay, and a function is also a subset of X cross Y, and it takes X and give Y. Relation also some takes X and give some Y. But the distinction between a relation and a function is, from examples, if I have to tell, this is a relation, not a function. So every function is a relation. And this is a function and a relation as well. So this is, a function is a subset such that so basically, so it's a subset of x cross y. This must contain for all x in it. Another thing, this is one of the conditions. There is another condition. For a given x, there is a unique y. So like the must condition eliminates function like this, but what if the relation is like this? But what if the relation is like this? Okay, so we are not dealing with these kind of things. So for every x, there is a unique y in y such that, and those ordered pairs, unordered pairs constitute a function. So basically it's a subset of x cross y. So there are two sets, one is called domain, one is called codomain in context of functions. So now can you tell me if 0 cross r, so I have defined f something from r to r, so r cross r is there, and 0 cross r is a subset of this. Again, there are like lots of ordered pair, it's a subset of r cross r. Is this a function or not? If it in terms of line, this function is a relation, basically a subset. Is this a function or not? So it's not a function, but r cross 0, that is again a subset of r cross r. This corresponds to y is equal to 0 on geometric 2D Cartesian plane. This line, this is y is equal to 0. This is a function. Is it injective? It's neither injective nor surjective. Okay, and when you want to find the range, you do something like this. This is f of x minus 5 by 2. In simple line, I would say the best way in this dimension is just to plot it. So it is like x is equal to 0, it's 5, simple line like this. The range is R. Is this clear to everyone? Okay, so in this question I want to see creativity. How many ways can you guys give me to sum this up? Just tell me the answer if you have it. Yeah, yeah, it's a GP series, yeah. So the best way is, when you want to do something like this, is just calculate till some capital N, because infinity is weird. Okay, so you want to do something like this with using GP series. What is this sum? Anyone? Yeah. So okay. So he's written 1 by 2, 1 minus 1 by 2 to the power n divided by 1 minus 1 by 2. This is 1 minus 1 by 2 to the power n. Capital N, sorry. And then you take limit n goes to infinity, right? So that means when you want to write something like this, this is what it means. Just a short question. So like for a given epsilon, so I'm saying this, right? This thing, right? So whenever you want to show this, what you have to show for a given epsilon, there exists for all greater than equal to m, this. In our case, xn is, I'll just write capital N. So for a given epsilon, can you tell me what this m is? This is just an exercise to get you used to like sequences. I have told you some epsilon greater than 0. You have to find me m such that this is true. It's a good exercise to do in a very simple setting. Should I do it? Didn't even find it. It's very simple. So xn, I've already said that this can be so this can be written as 1 minus 1 over, just put it over here, 1 minus 1 to minus 1, take the mod, this becomes 1 over so what happens? Epsilon is positive. Okay, you take ln, okay, now what? Now if I choose M to be one second. Yeah, so something like this, ceiling of this, then for all n greater than m, this is going to be true. So this is how you obtain, like, so I have given an epsilon, you have to give this n. This is how you evaluate, like you go opposite, like you do reverse engineering. If you know some form of xn, do something like this, do something like this. This is actually negative, but you're not operating anything, just bringing this down. This is m. So let's say you give me an epsilon. What I will do is, and sorry, this and maximum of this, because this is negative as well. So you give me an epsilon greater than 0. So let there be two cases. So you either give me epsilon greater than 1, you give me epsilon less than or equal to 1. Okay, in that case m is 0. Sorry, if it is greater than that, then m is 0. Otherwise m is, so when epsilon is less than 1, this is, one second, yeah, this is negative. For epsilon, took ln. So when epsilon is greater than 1, this is negative. When epsilon is smaller than 1, m is okay. Now when you want to do this, your xn is given by 1 minus 1 over 2n. So for all n, for this case, greater than equal to n, and n is greater than m, some positive number, right? And this is bounded by 1. Or in this case, this shows n equal to 1. Just the equality I'm trying to settle it down, yeah? And this is less than 1 and epsilon is greater than 1 in this case. So this is satisfied. In this case, again, you can do it. One n is greater than equal to ln over 1 over epsilon over ln into. This means just for consistency. Yeah. And you have this. It doesn't matter if there is equality or not over here in the definition. This is what, whenever there is a sequence and stuff like that, we need to deal with this. Given an epsilon, so I have two cases: when epsilon is greater than equal to 1, m is 0; when epsilon is less than 1, m is this. In both cases, I show that xn minus 1. Is this clear? Okay. Okay, so I'll stop the class over here. This will be uploaded on YouTube. I will upload the notes as well. You can ask questions. There is a forum as well, but I would like for you to interact with me. Keep your questions, ask in the next session, do your assignments. If you have, I can't discuss current assignment, the assignment that is pending, but if you have specific doubts in them, like if you want to clarify a question or something like that, you can ask. Okay, remember one thing, like solving a problem is the first step. It's not the final step. Like after solving the problem, you need to think about it. Do you understand it? Do you understand it like with algebra, with geometry? Can you think about it? Can you think about it in higher dimensions? Can you think about it in general? Can you think of some applications? That will be really good for your mathematical education. Okay? And if you have any questions like that, you can ask me in the next class. You can stop me. Okay? And that will be really helpful for you and me as well. Okay? So see you in the next class. Yeah, bye. Yeah, thank you, Siddharth.